This week we're talking about adding and subtracting rational expressions. So we want to start with something basic that we know how to do so that we can relate it to the polynomials again. So we know how to add and subtract fractions, which that's what we're going to start with. When you're adding and subtracting fractions, you have to make sure that you have a common denominator. So I need a number that both 3 and 5 can go into, and I know worst case scenario, if I can't come up with the number myself, all I have to do is multiply the two of them together. So I know I'm looking for 15. So in order to get 3 to get to 15, I need to multiply it by 5. And whatever I do to the denominator, I have to do to the numerator as well. So this actually turns into 10/15. Okay, in order to have 5 turn into 15, I need to multiply it by 3. And again, I have to do the same thing to the numerator. So this turns into 12/15. Once my common denominator is reached by doing my multiplication, I'm going to go ahead and add my numerators. So 10 and 12 gets me 22/15. And I keep the denominator the same. So all I do is add the numerators, keep the same denominator. So that's how you would do it with the basic fractions, like what you did in elementary school. Let's look at it with a little bit more difficult situation going on. So here is our situation. We do not have like denominators, so the very first thing we have to do is come up with like denominators. And we're going to change them by multiplying the top and bottom by the denominator of the other fraction. So this fraction is going to be multiplied by y plus 1, because that's the denominator over here, and I'm going to do it to the numerator as well. So this fraction becomes 2y plus 2 over, and I'm just going to leave this in factored form because that's what's going to serve my purpose best later on. Okay, and to get this to have a common denominator, I'm going to multiply by the denominator of the other fraction. So I'm going to multiply by y minus 1, top and bottom, y minus 1. So I'm adding to it 2y minus 2 and y plus 1. Y minus 1 is my denominator. So now that I have like denominators, I'm going to go ahead and step 3, add my numerators. So I have 2y plus 2y gets me 4y, and 2 plus a negative 2 gets me 0. Then I keep the denominator the same. So y plus 1, y minus 1. So that ends up being how you add rational expressions. Now if this was a minus sign in here, the only thing I might do different is I would change it to plus, and I would attach the negative sign to this 2 that's in the numerator. We just have to remember that subtraction is the inverse operation to addition. So it's the same thing, we're just having to deal with a negative sign that we have to carry through. So let's try it with some more difficult situation here. This one not so much. Okay, we have to get a common denominator, and you can see we already have a common denominator, so my job is just simply add the numerators. So I have x plus 4x, which gets me 5x. I don't have a constant here, but I do on this one, which is a negative 2. And then I keep the denominator the same. Now with all of this, we want to do what we were doing in the last lesson, which is look to see if it can be simplified. This one can't be simplified any further, so we're good. Let's go to the second example. Example 2 and 3 get increasingly harder. Okay, so you can see we don't have like denominators here, and we have subtraction. So what I'm going to do is I'm going to change this from subtraction to plus, and I'm going to attach that negative up here with that 5. And then I don't have to worry about it later on. I know that 5 is now negative, and it will carry through the rest of the problem. So my next job is to get a like denominator. So I'm going to multiply the bottom by the other denominator, so x plus 8, which means I have to multiply the top by x plus 8 also. Okay, so that means this one over here becomes 7x squared plus 56x. And my denominator is x plus 8 and 3x minus 2. And now I'm going to be adding, just like multiplication and division. We change division to multiplication. Well, I'm going to change subtraction to addition to make my life easier. So I'm going to multiply the top and bottom by 3x minus 2 so I can get that like denominator, 3x minus 2. So now that negative gets carried in because I'm going to be multiplying by negative 5. So I actually have negative 15x plus 10 in my numerator, and my denominator is x plus 8 and 3x minus 2. So now that I have like denominators, I just need to add my numerators, and they're like terms. So I have an x squared term, but no x squared term on that one, so it's just 7x squared. I have 56x here that I'm adding negative 15x, so it's actually 56x minus 15x, so that's 41x. I have no constant on this one, but I have a 10 here, so that's plus 10. And then I just copy my denominator, x plus 8, 3x minus 2. Okay, so let's try example 3. So example 3 is a little odd looking, but we're still going to do the same process. It's plus. I don't have to worry about taking a negative sign somewhere. I'm going to multiply the bottom by 8 and the top by 8. So that will get me 24 over, well, 8 times 7 is 56x squared, and 8 times 9 is 72x, so minus 72x. And then for this one, I'm going to multiply the top and bottom by 7x squared minus 9x, 7x squared minus 9x. So I'm adding 35x squared minus 45x over, and the same denominator, 56x squared, 56x squared minus 72x. So that's going to equal, if I put things in standard form, I have 35x squared minus 45x plus 24 over 56x squared minus 72x. Now some of you might have taken this example and factored off the common factor that was in here, and that would have been fine. You would have seen that the common factor here was x, and that leaves us with 7x minus 9. But the same thing would have happened. We would have had to multiply this side by the x and also the 7x minus the 9 because it's missing both of those. So there's actually 3 factors in this denominator now. Okay,